Hello there everyone, you've tuned in uxwbill. I'm finally going to put to rest the subject of a video that I should have made a long time ago. For all of you relative newcomers to this channel, it probably won't make a lot of sense to you because you don't have much context unless you've gone back and watched all of my old videos. But those of you who have been here for a while, you know what this is. This object needs no introduction. Yes, far too many years after the fact, I have finally decided to turn my attention to College153's mini refrigerator. And this is it. I dug it up out of storage, and we're going to take a look at it and see what actually might be wrong with it. It's actually a bit of a misnomer to refer to this as College153's mini fridge because this actually belonged to one of his previous employers, and when it stopped working, he more or less snuck it out of there. Nobody ever noticed it was gone. Nobody ever complained that it was missing. I expect at this point it's never going to be missed. And I really don't think this is going to be so much a repair video as it will be some kind of a post-mortem and a sense of closure to something that I should have finished a long time ago. I really have nothing witty to say here, no clever excuse for why I didn't get around to this thing. It just didn't end up being in the cards. And while you can't see it right now, the shirt that I'm wearing is probably the wittiest remark that anyone could think of right now because it says in big block letters on it, "Nope, not today." There was a whole lot of not todays. But I do eventually get things done, even if it takes me a while. That includes some other projects that I have backburnered, including some things that other people on YouTube have wanted me to work on for them. I'm not really particularly proud of that either. It's just one of those things that somehow or another they fell to the bottom of a very long list of things that were going on. Now, if you want to see a video discussing theory of operation of these things and a detailed diagnosis where I go through it step by step, you probably want to watch my previous video about repairing a thermoelectric cooler based mini fridge. That is exactly what this is. I didn't know that miniature refrigerators were actually made basing on this technology. So all those years ago, when College153, my rarely seen brother, he's the second oldest in line, I'm the oldest of the bunch, when he came to me and told me this didn't work, I assumed that it was a compressor style refrigeration system. And so the advice I gave him at the time wasn't really particularly relevant. And not until I came across that Black & Decker thing years later did I finally realize that perhaps there was more going on here than met the eye. That's not quite true either. That's not really quite correct. But this is unscripted, real-life video making as it happens, folks. When I saw this thing, I knew that it too was a thermoelectric cooler based design, something that really surprised me at the time. Speaking of things that surprised me, well, the first surprises no one. Although you get a block diagram here on the back, it really doesn't tell you much of anything informative about what's going on in here other than this is a semiconductor electric refrigerator. This has just one thermoelectric cooler unit. You can see that the power input is rated for 70 watts, which seems about right based on the experiences I had with the Black & Decker one, but rather more surprising is the presence of an air filter that you know nobody ever cleaned. It's not very dirty because I think this thing was probably only about 3 years old when it died. I'm basing that on the assumption that the beginning of the serial number, which starts with 0611, indicates the potential year and week of manufacture. Here you have switch mode power supply board. And again, I would be very surprised to find that something on it hadn't gone wrong. Already I can see it's got a case of crappy no-name capacitors, but none of them are actually bloated up. However, that doesn't mean that their ESR specification, their effective series resistance, hasn't just gone absolutely through the roof and caused this power supply to be unable to work. I don't really want to chance fireworks, so not even going to bother plugging it in. Just going to take these leads off of the board here. Of course, they're all zip tied together. So I'll clean that up in just a minute so I know what I'm actually working with. And then we'll dig up the trusty variable regulated power supply and see if I can figure out what might be bugging this thing. Well, if there was any doubt in anyone's mind that this thing is an incredibly cheap Chinese piece of junk, and that's no doubt why it didn't live very long, it was soon dispelled when I went to look at the power supply a little more closely in the name of derouting all this wiring and taking the zip tie off of it. I just touched this, and it's held in by a plastic tray, and the plastic isn't even yellowed, nor does it show any other obvious signs of aging, but it's incredibly brittle. I mean, watch that. I can just break that right off. There's nothing to it. There's just no structural integrity whatsoever. And this power supply board, they did a few things properly in my opinion. There's a fuse on the secondary side, which is surprising to see. It actually may not be as good as I'm giving it credit for being, because usually when these things have a fault on their secondary side, they should shut down in an orderly fashion, and maybe this one was just so incredibly badly designed that the idea was the only thing that would stop it was to blow a fuse. For some reason there's a red LED on here and there's a green one. I have no idea what those are for. Around this inductor and the area of the fuse, the circuit board is visibly discolored. For some extremely curious reason, they took this LM358, I believe that's an operational amplifier, and they socketed it. Why would you ever do that in a finished product like this where nobody's ever going to service this thing? And look again around the circuit board in the area of the power connections going to the thermoelectric cooler, and it's just heavily discolored. I really think that this thing just failed as a result of too much heat. Yeah, this is just a joke. And look at this soldering job on these power connections. Anybody could tell you that was done by hand. I think the whole thing was probably assembled by hand, because some of these resistors don't even sit flat with the board. You can see a green colored resistor right there that's poking up a little bit proud of the board. Here's a regular resistor over here standing a little bit proud of the board. Where did I see it on here? It looked like maybe somebody worked around an error in the design, or maybe there was a bad trace, although it doesn't look like there should be any connection between these two. Maybe this saved them the expense of going to a double layer circuit board. What an awful joke this thing is. It's a wonder this thing could even claim to be Underwriters Laboratories listed. Of course, that assumes the listing wasn't fake, and it could have been. I just don't even know, but this is pretty terrible. Over here on the primary side of the supply, one of the 4 rectifier diodes, and again there's heat stress around these things, which suggests they were probably really rather underrated for the capacity of work they had to do. But one of them standing just a little bit proud of the board, and the other two, where are the other two? Oh, they're right next door to that little transformer coil there. Might be a choke, I'm not 100% sure. But those two are level, and one of them there is, but yeah, I just don't know. And then there's some sort of a notation for a negative thermal coefficient device. I don't know if that was supplied via an external component, if that went to something inside the cooling cabinet, or just what that might be for. My guess is that it would have been some sort of a current limiter to ease the load on this probably already highly questionably specified power supply, and it's just not even there. It looks like it should have... No, I take that back. There's no way it could have been there. It's just flat out shorted with a blob of solder. So evidently that simply didn't fit on the bill of materials. Wow, what a piece of garbage. That board's not even... That's not even worth repairing. But let's turn our attention to what might be going on here. I don't know what all these various wires do, but we'll figure it out by trial and error. Now, since I don't really give a care about any of this stuff, I could just cut the connectors off of it and have done with it, but I figure we'll do this the right way, mainly because it lets me segue into a rather entertaining story. This is a box of ACO paper clips. These make great momentary connections for these female style connectors that plug into header pins or shrouded sockets on a board. You just stick these in there, and they're a great way to make tests without destroying the connector or damaging it. These were all of 69 cents at an area Walmart, and amazingly enough, they are actually made in the United States of America. But that's not the real funny story. In fact, I actually am really thrilled to see that. I deliberately was seeking to buy a domestically produced product, and I was glad to see that such an option was available. The thing that struck me so about these really caught me off guard. When I walked up to the checkout lane, or the till as our friends across the pond frequently refer to it, the woman who was operating the register asked me not only if I wanted to apply for a Walmart credit card, but also if I wanted to put today's purchase on this. And I should have probably said something sarcastic and witty like, sure, 10 more payments and these bad boys are gonna be mine. A dime a month for 7 months, because there's a remainder. But instead I was just absolutely incredulous. I said, you really are asking me that? I'm buying these with pocket change. I just absolutely could not believe it. So these two large leads right here, they're the thermoelectric cooler. And I just went ahead and clipped them right off the power supply board because, well, who cares? And we'll see if my variable regulated power supply has enough moxie to start these things up. I don't know that it would, but we'll soft start it and just see if the thermoelectric cooler itself is any good. Well, actually, I could use the multimeter for that task because not only did I find the good test leads, but I also found the very nicely shrouded alligator clips that I had wanted to use when I made the last video. They were on the floor. I found them when I was picking stuff up out here. So let's just go ahead and get clipped on here and find out if the thermoelectric cooling element is any good. Let's see, I don't think I'm making real good contact here. I'm getting very high resistance readings on my multimeter. 160.5 ohms. That's quite a bit higher than the other thermoelectric cooler assembly on the other fridge. I wouldn't have expected there to be that much difference. Given the higher resistance, maybe this one will be a little more within the capability of my variable regulated power supply to power it up. But when we do that, we'll get that hooked up, and we'll turn this on. The decimal point doesn't always light up in that thing like it's supposed to. And then, hopefully I put my dual input thermocouple thermometer back in the box, which seems that I actually did. And we'll haul it out. Let's see, thermocouple 1. I always get so tangled up in the box. I mean, yeah, I'll know that this thing's getting hot because I'll be able to feel it, but there's no way to convey that to you in the viewing audience. So we'll crank open our current limit here. And I'll live. Oh, my decimal point went out again. Okay. I'm not sure this thing's going to be able to run this thing. Because I am running right up against the current limit at 12 volts. Alright, change that to Fahrenheit. Make sure we're on thermal input number 1. Oh, that just fell off. In order to avoid arcing, we'll I don't feel this thing getting hot at all. I'll let it run for a couple minutes, and we'll just see if it actually manages to warm up. As I'm sure you can see, the temperature is steadily increasing. The heatsink has also been growing noticeably warmer to the touch, so I think it's a pretty safe bet that the thermoelectric cooler element in this particular unit is actually still good. I shouldn't let it get a whole lot hotter than it is right now, without the aid of the fans cooling it, because the junction temperature is actually likely to be several degrees higher than that. And while I'm far away from the danger point where its maximum ratings would be exceeded, I don't know why I don't want to burn it out. I mean, it's obviously a piece of junk. But the other thing that you'll notice is that the current draw has also dropped off slightly from where it was earlier. And it continues to fall as the elements reach their normal operating area. Isn't that just a fun-looking little setup? In the comments section on the previous video, a number of people suggested that these things were marketed in a misleading fashion toward people who wouldn't know any better, in that they're sold as being a kind of refrigerator rather than some sort of special purpose item like a drink cooler, whose naming would seem to preclude use as a general food storage area. These people indicated that food spoilage was a very real risk with these things, and I'd have to say that I concur. They don't perform anything like as well as a conventional refrigerant-based refrigeration unit would. In fact, I think this one actually performs a lot worse than the Black & Decker unit that I was looking at the other day. Now, some of my reasoning here might be a bit nebulous, but I hope you'll bear with me. First of all, the temperature that we're looking at here right now is the temperature of the outlet heatsink. And the Black & Decker's heatsink, although it was much, much smaller, it certainly got quite a bit hotter. And a heatsink that's getting hot is actually one that's doing its job. That's what they're supposed to do. And this thing is just as cool as it can be. The air coming off here is only barely warm. Now, over in the refrigeration compartment, things do look a little bit better. We just dropped below 40 degrees, although only just, and that's on the air outlet side of the other end of the thermoelectric cooler. So that's the best case scenario numbers that you're looking at right there. And while I'd certainly consider that pretty acceptable performance, this garage is much cooler than it was the other day when I was testing the Black & Decker unit. It was about 95 degrees in here. By a very conservative estimate, it's about 72 degrees in here right now, because we've enjoyed a bit of a reprieve from the hot weather that we're having here in the flatlands of Illinois. But the Black & Decker, even with those incredibly hot room temperatures, still managed to pull off a 40-degree spread pretty easily, and it showed no sign of stopping there. It seemed like it was going to cool down a fair bit further, which, considering that it was only running on one of its two thermoelectric cooler units, I have to say was an exceptionally good performance. This heat sink was well above the 90-degree mark. It was easily 110, 115 degrees Fahrenheit, somewhere in there. And like I say, the temperature spread was around 40, 50 degrees, somewhere in there. I don't remember the exact numbers for sure, but I know that I was both surprised and impressed with its performance. Here the room is much cooler, and this unit just doesn't seem to be doing the job of exchanging heat that the Black & Decker was. Although we have reached a 42.3 degree temperature spread. That's the difference between the temperature reading that I'm taking here at the heatsink and the air outlet inside the unit, or the delta T as it's also known. So there again is the temperature that's being taken at the heatsink. It's not really as hot as I would expect it to be. And then there's the temperature inside the box in the path of airflow coming off of the cooling end of the thermoelectric cooling unit. So I just don't think this unit is quite as good as the Black & Decker, because it's not behaving as aggressively. And these conditions, this is pretty much normal room temperature right now, especially during the summer. This would be a very cool room temperature for most people during the summer. This thing ought to be doing leaps and bounds better than it is, in my opinion. But now you know the entire story of College153's long ago forgotten mini fridge, if you could call it that. I think this unit's probably going to end up being parted out. These two cooling fans down here on the bottom of the heatsink, they seem to run perfectly well, so I'll probably just pinch those off there and save them. I don't think there's a way in the world I can save the thermoelectric cooler, so the rest of this unit's probably going off for scrap metal somewhere, especially since it's just so cheaply made in so many ways that I don't think it's worth repairing. I really don't. So, thank you as always for watching, and I certainly do look forward to hearing your constructive commentary. Seems we've had a little bit of a problem with some people not understanding the definition of that word as of late. You know, I welcome all sorts of opposing viewpoints. What I don't welcome are people being YouTube jerkheads, and it just seems like it's YouTube jerkhead season as of late. And you know, some people disagree with my decision to moderate the comments as I see fit. I'm a pretty easygoing, freewheeling guy, but there are just some things that aren't going to happen, no way, no how. So don't push my buttons, because I don't give second chances anymore. I've been tired of that sort of pointless crap for a very long time, and I just won't put up with it, if you'll forgive my foray into excessive honesty territory. Before I wrap this video up, I'll let this unit run a little while longer. We'll just see what kind of temperature spread we end up with after it's been running for, say, an hour or so, just as another data point. So thank you as always for watching, and again, I look forward to hearing your constructive commentary, even if it's off topic. I'm certainly interested in hearing what you have to say, as long as it has any sort of a redeeming aspect to it. So as previously promised in the course of this video, I've returned to give things a quick wrap-up, although it's probably not going to be as quick as I'd hoped, because I think I might have been thinking about this the wrong way, might not have expressed myself particularly well when I was discussing this particular situation earlier. In particular, I'm talking about the temperature spread. Now, previously I had mentioned that the Black & Decker thermoelectric refrigerator had managed to develop between a 40 and 50 degree temperature spread, and I'm wondering if, as long as the heat output of the thermoelectric cooler, the output end, were not to become saturated, if that spread would simply be maintained within the device's limits over a wider range of temperatures. I didn't think about that earlier, but as long as the device could shed enough heat from itself to maintain that 40 or 50 degree spread, I'm wondering if that wouldn't be the case. I'm still not sure that I'm saying what I want to say throughout the course of this, but if we look into things now, this has been running for, about an hour and a half. I went inside and watched some television while I was waiting for this to complete, because I really didn't have anything better to do at the time. And on the hot side, well, we're pretty close to ambient. We're just about 5 degrees above what the temperature here in the garage is right now. And on the interior of the refrigerator, we're almost to the freezing point, which, given the lower indoor temperature that the heat-facing side of the thermoelectric cooler is facing right now, does seem like it would make sense. And we have a spread of basically 43 degrees. It's fallen off a little bit. It was reading 42.6. Now it's dropped down to 42.4. Now it's back again. Of course, I really doubt that this inexpensive thermometer is anything like that accurate. It's just to give you an idea, to get into the ballpark. But as you can see, our temperature differential is definitely right around the 40 degree mark, and that seems about right for one of these thermoelectric coolers. I still think that in some sense the Black & Decker unit works better. I'm not sure I can really qualify that in any meaningful way. It's pretty late, and I probably ought to be in bed instead of contemplating editing and uploading this video. But that is the whole story. Evidently this is another case of a severely underrated and very cheap power supply conking out after just a short period of time. I'll give the Black & Decker credit. I think it lived a lot longer than this thing did before it finally laid down and died. And of course it was, in my opinion, the better built of the two. And I'd say that even if it's not the unit that I purchased back in the day. I didn't buy that one brand new. I bought that at the Goodwill. But it's time to go ahead and wind this thing down. So as always, thank you for watching, and certainly do feel free to leave a constructive comment if you happen to have one.